What's up, everybody? What's up, Zach? Yeah. All right, dudes. So I am almost done editing that trig video. It will be out eventually. It will eventually go out. Yeah. Vena's in chat. What's up, Vena? This is my good notebook, so I'll put this away. How's everybody doing today? Wednesday. Yeah. What's up, Russo? Arnold Schwarzenegger's joined the chat. Maybe he'll be good at math. So I had some ideas on what we could work on today. Right before this, I was editing that trig video, so I didn't plan anything. But I was thinking that we could talk about some graphing material that you probably can get your head around. I also can talk about some grammar too. But the main thing I do want to talk about today is kind of graphing and taking a step back. The video must have Bill de Blasio in it. Yeah, he's not gonna get featured. He's not gonna get featured until he agrees that the SHSAT is a decent test. But until then, he's not gonna get. He doesn't get the feature. He doesn't get the feature. Yeah. So I guess basically what I'm kind of getting at for this work today is the idea. Look at, by the way, one of my pens is bleeding. I don't know which one it is, but one of my pens, ooh, yeah, it's this guy. Ooh, I hope he's okay. So we'll use this guy today. One of the concepts I wanted to go over is why graphing? What does graphing do, or what does it symbolize? And graphing is not as much like you absolutely have to know how to do it in order to get by on math. You could fake it and just algebraically do it, but with graphing, it kind of helps visualize kind of generally what our solution set is. So I guess this is going to be our coordinate plane. You need help with this. In triangle NBC, the median AM satisfies that AM is greater than 1/2. Well, hold on a second. I just popped out of the window. Where are you? Is 1/2 BC. Prove that angle BAC AC must be acute. There is no diagram. Okay, so let's see if we can help Rusum with this problem. We will come back to graphing in just a second. This problem seems hard. I don't know what the solution is yet, but this seems like one of those problems that on the surface is kind of simple, but on the back end, not simple. So really quick, the first thing we have to go over is what a median is, okay? And a median is a line that goes from the corner of a triangle down and bisects the opposite side, okay? So it's kind of important. It's the midpoint of the side that it goes through. So let's hit this triangle first. M, or I guess that's now our B, C, and M. And then we have a median of MA, and MA is the midpoint between here and that is our median there. Okay, cool. So we know that AM is greater than 1/2 of BC. So that means that this line here is greater than this line here. And that's going to be important for a second. Prove that angle BA, prove intersects the midpoint of one of the segments? Yeah, intersects the midpoint of one of the segments, segment BC. Because I'm assuming AM, this would be your M, that's your A. So prove that angle BAC. Yeah, you know, I don't really see an angle BAC in this. So, are you sure that you wrote this correctly in the chat, Rusum? Because if we have a median AM, that means it needs to include point M, and it's going to bisect BC, or it's going to intersect the midpoint of BC. So there is, I mean, angle BAC, they're all on the same line. So I don't really see, maybe there's like a typo in your question or something, because I just don't see how that can that can make sense. Unless you're saying that BAC is 180 degrees. But then again, that would not be anywhere near acute. So I don't know what to tell you, Rusum. Maybe it's a typo. If you do get more information on this one, we can talk about it. But from my perspective, just the way that the problem's written now, I don't really catch it. But good question, though. good question. I actually have a good question that we can base off of that. That if you guys, you meant to wait. Oh, okay. All right. So he meant triangle ABC. Okay, that's what I thought. I was like, that's kind of weird, but I was like, I kind of like that, how it's not in order. And so AM is going to be this here. Okay. That makes sense, my guy. Okay, cool. So that's M in here. And so what it's saying is that this line is longer than this, or longer than that. So that's the information that we know, because BC, right, this would bisect it. So it's going to be bigger. So this line is bigger. What does that indicate? Who knows? So we need a triangle BAC must be acute. Well, yeah, it has to be acute. Like 100% it has to be acute. So, okay. You just find out about the Korean SAT? Senseong? Yeah, dude, Korean math is legit math. Like, you think you're good at math? Like, take a Korean math course and you will be revealed. All right, so let me show you, Rusum, why my instincts are like blaring off on this one. So I'm gonna draw 3 triangles here. I'm gonna draw a super obtuse angle for A. We're gonna draw a right triangle for A, and then we're gonna draw a let's say super acute triangle for A. This will be B, this is our B, that's our C. All right, chill. So in this one, our M is going to be this guy right here. And just look at this diagram. Like, there's no way that angle M is going to be longer than this MB. Do you see what I'm saying here? Whereas the right triangle, we are going to get a nice 90-degree angle there. Okay. And so because of that, I mean, this is, if that's 90 degrees, I guess this could be further out. So it's not as like normal. So I guess it doesn't have to be a right angle if it bisects the line there. But with this acute one, notice how it's much more obvious that this one is going to be longer than our MB here, right? So because of that acuteness, because of this acuteness, that means this line is going to be the shortest, you know? Whereas if this is the biggest angle, this line is going to be the biggest in the triangle. So how do you prove that? Well, what type of proofs are you guys working? Like, how advanced are you guys getting on your proofs? You know what I mean? Like, are you just using like angle side type stuff? Are you guys using trig? Or like, what type of proofs are you guys getting into? I guess that's going to be my question. But the concept holds up. So as far as I'm concerned, my teacher says this: the proof is best done in paragraph form. This one is fairly tough. Try to convert the given into other inequalities that tell you about the angles in the triangle. Okay, well, I guess you could do that. So the question itself does say that this AM, is going to be bigger than 1/2 BC. Okay, so just looking at this triangle right here, if this line is longer than this line here, then that means this angle will be bigger than that angle here. So that's whoops, let me catch up to the chat here. The triangle inequality. Oh my god, I hated truths. Yeah, me too, bro. So because this side is bigger than this side, we know that this angle is going to be bigger than that angle. I guess I could try to draw this. I don't know. It's been forever since I did proofs for real. For real, my guy. Yeah, that would be longer. I guess it would be. You could do something like that, where that's A, and that's B, and that's M. But even then, this would still have to be smaller than this. And this angle, yeah, is that side length, so it will be smaller. So I don't remember the name of the law, Rusum. I don't remember the name of the law, but it is true. It's 100% true. No matter how you draw it, this AM, if it needs to be longer than MB, if AM is going to be longer than MB, you're not going to have an acute angle inside here. Well, I mean, you might have an acute angle, but it's not going to be that acute, my guy. So, oh, Animation Space is back. What's up, man? So, yeah, that's kind of how I would attack this one. As far as what the proof goes, I mean, you could manipulate this, and then by this, you could say that angle BAM is going to be less than, and that's kind of confusing, less than angle ABM. So I mean that could be a good start for you. No, dude, I got paper. Let me tell you, I got stacks. I got racks of paper. So don't even worry about it. All right, so that's an interesting problem, I must say, and I'm going to throw a trig problem your way because we have been working on trig problems, and it's actually kind of a similar problem. So let me actually, I forget where I saw this originally, but it was something like this, where there's a triangle here. All right. All right, so it would say, So then what could we do? We could do like the... All right, cool. So here's like a trig question that's very similar to Rusum's question, actually, where you have to add a point to a line. This is exactly that, but we threw some trig into it. I guess trig is on my mind since I just made like I've been spending the last 2 hours editing this stupid trig video. I can't wait till it's done. It's been taking me forever, way longer than normal. I've like had to re-record it 3 times, but it will come out eventually. Yeah. So whenever you have an answer for this, you can just throw it into the chat or whatever. Sup, Chang? Oh, I should have put like a like timer up on this guy. Well, better late than never. Okay. Shiba. Zach. Impossible. Gruesome. Impossible. That's funny, bro. Yeah, it's possible. I'm telling you, bro. I'm telling you. But you got to know your trig rules. That's for sure. 45 more seconds, and then we'll cap it off because I feel like my chat's good. Smart chat. Good job, chat. I'm so proud. I'm so proud of my chat. It's small but mighty. It definitely is small, but it's smart, man. All right, so we're kind of near the end here. If you can't feel it now, well, chances are you just are missing the rule that will help you with this, because it's if you don't know the rule, it's just so hard. It's just so hard. Okay. So that is time. Let's look at this. Let's see if the chat's correct with the 0 here. So we're going to put D somewhere. I'm just going to put it somewhere kind of unconventional, a little off to the side, so it doesn't seem like we're absolutely splitting this 90 degrees, right? Hypothetically, D could be right there, right? You're just going to wait for the vid. Oh, did I miss sorry? Oh, big oof. That's my bad, sorry. All right, cool. Thanks, Russo. That's nice, Russo. Looking out for the other chatters. Looking out for the other Tyler Tutor chatters. Russo, if I had a sticker, I would give you one. DJ Russo. DJ Russo Weedle, Mr. Russo. Yeah, it's a simple spell, but quite unbreakable. Yes, I agree, Russo. So this is our diagram now. Flex, looking good. One thing that we know is this angle ACD and this angle BCD. What do they add up to? 90 degrees. So going into, come on, I have too many lights. My lights are crazy right now. Hold on. So looking at like a right triangle, right? That's 90. So these two angles, let's call them X and Y. X and Y are going to add up to 90. So let's just look at the values for the cosine of this X and the sine of potentially this Y. Because if these two angles add up to 90 and these two angles add up to 90, we can, I'm telling you, we can draw a parallel. So this is a Y, of course, because my handwriting is like calligraphy. The cosine of X would be this 4 over 5. The sine of Y would also be 4 over 5. So when you have any two angles that add together that equal 90, their cosine and their sine will be the exact same thing. Now, we could take the cosine of this angle, 3 over 5, and the sine of this angle, 3 over 5, it'll equal the same thing. So when two angles add up to 90 degrees and take the sine of one and the cosine of the other, or take the cosine of one and the sine of the other, those values will be exactly the same. So whatever this value is, it'll be the exact same as this value. And so that's why the chat, who are 167 IQ math geniuses at this point with with Trig, crushed it up so hard. Honorable mention to Rachel. So yeah, that's that problem. I thought that problem was pretty good. But you guys crushed it really hard, so I'm gonna have to think of something a little bit more difficult for you guys. And it won't be trig based necessarily. I do want to get into kind of like linear graphing and solving through graphing. But yeah, I mean, I don't know. I don't want to make it too easy for you guys. So I'm gonna whip up a problem really quick. I'm gonna try to make it difficult. I'm really, really, really gonna try to make it difficult. But we will see. So just give me like 2 seconds. I will be right back. Okay, so back. Oh, what's up, Henry? So, guys, check it out. Here is a kind of a. I thought I was making good handwriting, but something's up with my pad. Yeah, of course, it's not my fault that the handwriting is trashed here. It's the pad's fault. We all know this. But I will read it to you nonetheless. So, hats are $2, socks are $3 each. I made a total of $19 and I sold 7 items total. How many socks did I sell? Yeah. Ooh. All right, Jason. I see you. I don't know why you got those question marks there, my guy. Got more confidence. More confidence in your answer. The bandwagon is forming. Emily and Henry got on, and now it's looking like this wagon has wheels. Zach's on it too. Okay. Yeah, crunchy. I don't know, man. Yeah, it's at least one, Henry. I don't think that would be an answer though. At least one. Okay, sorry's got 5. Nice, sorry. Crunchy's on it too. Okay. Well, good for you, Crunch Hammer. Those trig problems were too hard. You came hard on this one. All right, that's enough time. You guys rocked this out. I'm interested in talking to you about this, though, because I'm going to give you a harder one next, and I'm curious to see how you guys solve this. So this is a system of equations. Hats are 2, socks are 3. So let's just say hats are, that's a really bad start to my life here. Hats are Y, and we'll say that the socks each are 3, and they're X. And we made a total of $19. So however many hats we sold for $2, however many socks for 3 is 19 total. We sold a total of 7 items. So let me actually rewrite these into a form that may be a little bit more familiar to you guys. Cool. So this is graphable. We have our slope and our y-intercept. We have our slope and our y-intercept. And if we were to graph these, it look kind of like this, where one line is going quick and the other line is not going as quick downward. And where they meet, this point, this value of xy is going to be the answer to the equation. So when we talk about graphing, this is the solution. Whereas before we talked about parabolas and this were the solution. If there are 2 lines, your solution is where those lines intersect. Slope-intercept form. Yeah. So from here, you could just make the equations equal to each other. That's easy enough. It would be negative 3 over 2x plus 19 equals negative x plus 7. I don't even really want to deal with that. So I'm just going to plug in this y value into this equation. And so what I'll end up getting is 2y, which is negative x plus 7, plus 3x equals 19. And we can roll through on this one. Negative 2x plus a negative, or plus a positive 14, that's on me, plus 3x equals 19. Subtract 14 from each side. This right side is 5. And x equals 5. All right, so chill. That's how that one goes down. This graphing, my pen is leaking, so it kind of looks like trash. You have to forgive me. But now I'm going to try to give you a problem that's not going to be as easy. And we'll see if you guys can hang with it or not. So you can't just plug in numbers. So give me 2 seconds. I'll be right back, and we'll be with fresh problems. Okay. So, bros, here's the problem. Very fancy. Let's see if you can apply your skills, okay? Obviously, this is a little bit trickier. I'm not going to tell you why, but I think you may know. So, let's get it. Oops, that's the wrong thing. Let's get it. Yeah, dude, Russo, yeah, I did get a new profile pic. I forget who was like roasting me because I was too lazy to make a new one, but now it's new. It's back in action. What's up, Shot? Yeah, you're good. Yeah, nice, man, nice. Yeah, gotta get your work in, bro. I'll give you guys 2 turns of the clock, so you guys have about 2 minutes left. I will say, though, now that we're halfway through, if you're graphing this on a calculator or on Desmos, you're going to be so much happier. All right, so we got 18 maybe. You rushed it. Ah, yeah. That can happen. That can happen with the SAT. Okay, Venna thinks it's 18-2. Shad's got 14. Shard. Got you. Yeah. Yeah. Well, you still have a little time. Sorry is on 14 too. Sorry. Do you guys check your work on this? Okay, we're going to be wrapping it up in just a second. So, with problems like this, if you have time, and obviously you guys all had time, it's super luxury to be able to check your answer. And so I'm going to check your guys' answers, and then we're going to know for sure if we're right or wrong, basically. So it's pretty evenly split. I'm going to start with this 14. So clock is off. So 14 pounds of this jelly cake. So it's 14 of the jelly cake, and it's going to be 6 of the fish. So 14 times 2 is 28. 6 times 7 is 42. Yeah, that's way too much money. Way too much money. Because we only spent $48. So that can't be how much jelly cake we bought. By the way, what is jelly cake? I feel like I had jelly cake for Thanksgiving, and it was kind of gross. It had like sweet potatoes in it. Uh, okay, yeah, dude, good to see you, Pokar. Yeah, man, Pokar is a kind of an OG. But yeah, welcome back, bro. So let's check this 18 answer. 18, so that would be $36 worth of whatever, and then $14 worth of fish. Yeah, that's going to add up to 50. So very close. Very close, but not quite. So this is why graphing is like legit. Oh, you have another difficult problem, Brewsome? Prove that the lengths of the altitude of a triangle cannot be... Oh my god. I think you've sent me that problem before, bro. That is super hard. That's super hard. Thank God that there's no proofs in the SAT. That's all I gotta say. All right, so this problem's very hard, right? Like, it's even if you just like plug in, numbers for the poundage, it might be kind of rough. So I'm gonna just rewrite this really quick and using y and x so that we can graph it. So let's say that our fish is the amount of poundage that we buy. That sounds weird. The amount of poundage of fish we buy is y, and then the amount of poundage of jelly cake we buy is x. And the poundage is going to add up, or I'm sorry, this is the price. The price. So the price is going to add up to 48. And the amount of pounds of fish plus the amount of pounds of jelly cake is going to add up to 20. So where do these two lines intersect? And that's going to be our answer. So let me actually pull up a screen really quick. This is going to be kind of impromptu. So you're going to have to give me a second just to make sure this. Let's see. Add, please capture my window. All right, here we go. Bang, we're in. All right, we're in. Cool. So this is the two equations. These are the two equations. And notice where they intersect, right? We can go right to the intersection here. And that's going to be our y value, 1.6. That's going to be our x value, 18.4. So that's why the graphing is so important, is because we can have the calculator do this work for us. We don't need to do the substitutions and the crazy division and all of that stuff. We could do it algebraically, or you can just graph both the lines, and wherever these lines intersect, we know that that's going to be a satisfying answer for the equation. So yeah, that's how this one kind of goes down. What are your guys' thoughts on it? Pretty cool, right? All right, cool. So that's how this one goes down. The answer for this, what was it? 18.4? Yeah, 18.4 pounds of that jelly. So 18 is really close. I gotta say, 18, as far as like a whole number answer, pretty legit. But if you check the work, it's not quite. It's going to be $50 worth. So you do need to buy like fourth of a pound, not fourth of a pound. You need to buy 4/10 of a pound, 2/5 of a pound of jelly cake. Oh, okay. So you got 18.4. Venna. That's tragic. So Venna got the right answer, apparently, but didn't trust yourself. Jordan Leung, that is not what you said. Wait, did you say that? This is like your first comment. No way you said that. Really? Oh, dude, he did say it. Dude, nice, Jordan. I'll give you that. That's back there. I was just explaining it. I was pulling up Desmos, my guy. I couldn't see you. But definitely shout out to Jordan. A half shout out to Venna because you didn't trust your math. That's why I kind of made it poundage, is because even a whole jelly cake can be like 1.5 pounds or whatever. So yeah, with poundage, yeah, if I was saying there were cows and eagles, you can't really have half. I mean, I guess you could have half a cow, but why would you want half of an eagle? You know what I'm saying? It's like, it's no longer, you know what I'm saying? It's no longer an eagle. So who buys that much jelly cake? Bruh, you're looking at them. I do. You should see my fridge, my guy, filled with jelly cakes. Actually, really gross. I feel like I did have a jelly cake for Thanksgiving. It's nasty, dude. It's like, why? Why not just make a normal cake? Why does it have to have like dangly bits of fruit in it? Like, I don't know, personal gripe. All right, cool. So let's see if we can get a redemption here for all the homies out there who unfortunately missed that last one. Not saying that that reflects on you at all, but I am saying that you can redeem yourself. That's all I'm saying is, in life there are seasons and there are times for redemption, and this is one of those times. Okay, all right, so that works. I'm just trying to make equations here. Let's see. Oh, I forgot to put my Be Right Back music on. But you guys get it. You guys get what I'm doing here. I'm making equations. You gotta let the magic happen a little bit. I don't really like that answer. Maybe I should make this a little bit bigger. Oh, that's looking much better. That's looking much better. All right. We'll do this. It's not really working out how I want it to. Come on. All right. Here's the redemption. Let me write this up. Let me rewrite this like this. uh, how many gallons are... Okay, so here's a challenging question, I would say. Here's your redemption, your opportunity for redemption to redeem yourself. So let's do it. Let's go for it. I'm gonna put on the clock. Oops. We are gonna get started here. Wrong one. All right, cool. Let's get it. Yeah, it's like a Mr. Beast video. I will take $20,000 worth of soda, please. I'm gonna fill a swimming pool with it. Like all of his videos, all of Mr. Beast's videos are like, we bought 10,000 bouncy balls, and look at what we do with them. It's like just a rich person just doing cool things with his money. That's like Mr. Beast. All right, so Poke's on 5. Check your work, Pokar. 5 gallons of grape soda times 550. That means 2 gallons of water. 5. Okay. Well, do you know exactly? Sorry. 5 point something, she say. Well, do you know exactly how much? Exactly. Because, like, this is what we're getting into, bro. We're getting into, like, the exact numbers here. So, if you want to pop open Desmos and throw a couple equations into there, that could be beneficial to you. We got Leung up in here, co-signing Poke. Russo. Sorry, just says no. I wish that was an answer for most of these tests, or you could just say no. You're just like, what is the square root of 131 simplified? No. Okay. Ooh. Okay. All right. So we got Crunchy 4.6. Yeah, Poke, dude. Desmos.com, my guy. Real quick peek. It's gonna go crazy, but yeah, that was a quick. It's an online graphing calculator. All right, Emily's on it too. Okay. All right. Pokar 4.2. Yep. 4.2. Zach is on 4.6 as well. That's exactly what I wanted you to do, Zach. Grab your calculator and go ahead. Poke, I already have you for 5. I'm going to write you again just because welcome back to the stream, my guy. Rusum, all right. Nice. Yes. Shad, yes. Very good. Jason, yes. All right. That's exciting. Good. You got to take your time, dude. No, you rounded up. Ooh, yeah. You're going to regret that, Russo. You really are. You do got to take your time. You got to find the right pace. Because even in a race, if you're like running a lap or whatever, and you like sprint the first part of the lap, your second half's going to be slow. So it's like all a pacing game. But yeah. All right. Oh, exactly. Ooh, nice pun, Crunchy. Okay. So that actually is pretty good. Exactly. 42, 4.2. Ooh, oldie but goodie. Some memes never die, Poke. That's all I'm going to say about that one. So let's go into it. I'm going to pull up my Desmos, but first I'm going to show you what equations I made. So $3 per gallon, let's just say that is going to be our Y value. So our two equations, our system of equations is $3 times however many gallons of water I buy, plus $5.50 times however many gallons grape soda I buy. And we bought a total of $32.50. So here's our first equation, luxury. The second, why does everything look kind of yellow? I'm like, I don't know why things are looking yellow around here. I got all my lights on. I think it's because some weird light outside is happening. Whatever. So the second one is the amount of water plus the amount of soda we buy is going to be 7 gallons. System of equations. All right, you ready? Implementation and Desmos. So here's Desmos. There are 2 lines graphed, right? And so if you're on Desmos, it's so easy. You can just push this button and here we go. We know that our X value, or our grape soda gallonage, it's 4.6. So we got 4.6 gallons of grape soda, 2.4 gallons of water, and that's our answer. Now, if you have the TI-83, you do have to do like trace, and you have to find the intersection, because TI-83s are basically the same technology that we went to the moon with, but they're still like $90 for some reason. So yeah, really, really nice. I gotta say, hold on. The redemption's real. Yes. The redemption is absolutely real. You guys, check your work. You can be like these guys, these absolute legends. Absolute legends. All right, so that, honestly, that's all I need. Now I can die. Like, I actually don't exist outside of this live stream. People think I tutor. I don't tutor. Outside this live stream, I don't exist. The camera goes off and I dissolve. I'm like a ghost, It's like every ghost has a job, and when they do their job, they can finally dissolve and go to their final resting place. That's like me when you guys get redemption. I can finally dissolve back into the ether until 6 p.m. Eastern Standard Time the next weekday. Yo, wait, the mean of 4.2 and 5 is 4.6? Very interesting. Very interesting. Whoa, so wait a minute. So you're telling me if you average both of Pokar's answers, you'll get the right answer? Whoa, Illuminati confirmed. Good job, Poke. Good job, Poke 2. You get a participation trophy, Pokar. These guys are winners. These guys get trophies and ribbons. Poke gets a round of applause and a participation ribbon. Good job, my guy. I'm just kidding, though. I know you can do it. I know you're just memeing. All right, so there's that. All right, I can't really. I'll maybe do one more, like a really hard one. But I feel like you guys are so good right now that I don't know. Let me see if I can think of one that would be like a little bit more difficult. Ooh, yeah. I think I got one that would kind of challenge you guys a little bit. You are too cool, Poke. So, all right, I will be right back, and I will be back with a just the freshie of the freshest problems. And we'll do one more, and then we'll cut it. So, just kick it for like 2 minutes. All right, we're back. So, can you put a picture on top of another picture in MS Word? Yeah. Oh, why is this redemption song playing? We haven't redeemed ourselves. All right, sorry. Redemption's off. Okay. So here's the problem. Good luck with it. Can you put a picture on top of another picture in MS Word? Yeah, you can. You should be able to. If you adjust the arrangement so that there's no arrangement, then you should be able to do that. Okay, so here it is. Y minus x squared equals 5x. 2x minus y equals negative 10. If y is greater than 0, what is x? That's the question. Clock on. Let's get it. Jazz on. I'm just trying to relax, bros. What is the 25th percentile and 75th percentile in the SAT? My guess would be that that's probably around a 1250, a 1300 maybe? No, probably around a 1250. That would be my guess. X equals negative 8. Okay. But each test is different. Like, depending on the difficulty of the test that you get, the amount of incorrect will change your percentile. What does that mean? X? Guys, this just means X. I shouldn't even done this. X. What is the value of X? Oh my gosh. It's the value of X. Alright. I was just kind of bored writing it out. Why is it divided in 25% and 75%? There are other divisions of percentile. Like you can be in the 10th percentile. Ah, well, Jason, if you watched our other streams, you would have seen you could do this. You just gotta believe in yourself, or have Desmos, or have a graphing calculator, which is what we're gonna do. But I'm gonna show you how to do it algebraically, just in case, because there is a non-calculator section on the SAT. So. Dude, Russo, where are you getting these triangle problems, my guy? These are crazy difficult. Meantime, proof a triangle ABC with point P in the material of the triangle. AB plus BC plus AC. Well, dude, I mean, I could prove it to you by drawing it, but as far as like the actual triangle rules, it's just been so long since I did proofs. But I'll give you guys like another minute on this one. But then I do have to duck. I have a tutoring session at 7:15. I mean, I disappear into the ether at 7:15. I don't actually exist outside of these streams. Yeah, I think he is, Poke. Bing, bing, bing. Yeah, dude, I do too. It's like, I know what it is. Why do I need to prove it to you? Yeah, dude. And the funniest thing about proofs is that once you learn them, you never do them again. That's like the most hilarious thing about them, is that you spend like months learning proofs and then you do them and then you never do them again. Unless you like major in math in college. Yeah, I do. I do disappear after the stream is over. I dissolve. You know, like the Thanos snap, the gauntlet. That's like me. I disappear into the ether to just kind of exist. Okay, so that is enough time. Let's go over this. Let's talk about it. Yeah, I do disappear. Well, I'm gonna hopefully finish before 7:15. All right, that's enough. I've had enough of this jazz. Get out of here. All right. More time. Dude, I feel like I'm around the legends, honestly. You guys are smart. So here is our problem. Yes, you could just snap this through Desmos. Oh, whoops. You could just, wait. You could just snap this through Desmos and get your answer. No problem. But I'm going to show you algebraically how to do this. Why? Because we're cool like that. I'm going to solve for y on both of these. Boom. So we solve for y on both of them. Now, if this equals y and this equals y, that means they can equal each other. So x squared plus 5x equals 2x plus 10. Watch how slick. Now, to solve quadratics, which is what this is, because of that 2 right there, that's a quadratic equation now. We put everything on one side and have it equal to 0. So I'm going to subtract the entirety of 2x plus 10 from each side. So what I get is x squared plus 3x now minus 10 equals 0. Now we can do this. We can unfoil this guy. So 1 times -10, -10. What two numbers multiply to equal -10, add to equal -3, x plus 5, x minus 3, or whoopsies, x minus 2, because I'm smart. And x is going to equal either -5 or a positive 2. So here are our two values, but remember what the problem asks. Originally, that y has to be greater than 0. So I could plug in my x values into this equation, and we can see what our y equals. So y equals 2 times -5 plus 10. That would be y equals negative 10 plus 10, y equals 0. No good. We can't use that answer, but we can plug it in again and see if this 2 works, and obviously it's going to. Great. So when x is 2, y is 14, and this is our only answer. If we snap open Desmos, that's exactly what Desmos says too. Because when x was negative 5, y was 0. And when x is 2, y is 14, that's where they intersect. That's what's up. So I highly, highly encourage you to begin using graphing in order to solve these kind of heinous problems. Legends never die, bro. That's a good point, Crunchy. Legends never die. They just dissolve into the ether. That's going to be you guys. You're just going to dissolve into the ether. Once you achieve perfect intelligence, 190 IQ. Yeah. All right. So, yeah, dudes, that was the stream today. Yeah. I'll be back tomorrow. Dude, I'm dying to do some grammar. So maybe we'll do some grammar tomorrow. I don't really know. I'm going to release that trig video tonight. I'm going to do it. Tyler, email me at Tyler. Dude. Bro. All right, hold on. I got to focus to write my name here. There we go. He's doing it. All right. Wow. What a time to be alive. All right, that's my email. You guys are in the club. You guys can email me whenever. It's kind of nice because during the SHSAT, my email was like RIP, but now I can actually like see when new emails come in. Well, dude, I'm glad you came, Poke. It's been a minute. But yeah, I'm super glad that we can chill a little bit more low key with these streams. If there's something that you want to work on, like let's say there's something you're going through right now, don't know how to do it, email me and I can fold it into the streams. Do you know what I'm saying? So just keep that in mind. You're always welcome to email me, whatever. What a time to be alive. It's the iconic ending, Sean. What a time to be alive. That's so funny, bro. Yeah, so all right, dudes. I am gonna get out of here. It's time for me to get out of here, and I gotta get ready for this next tutoring session anyways. So I'm gonna duck. But bros, again, hit me up via email if you want to work on anything in particular. We're gonna stay grinding. I'm gonna stay grinding. Gonna try to turn this into an SAT channel slowly but surely. Yeah, you just gotta grind sometimes, bros. Even if you don't see the result right away, you gotta stay on the grind, and that's what we're gonna be doing here. So thank you guys for coming out. Have a great rest of your evening. I will see you guys tomorrow, 6 p.